retrieval. So that's the topic we can talk about it. We'll dive into that, and I will walk through. There's two part of it. One is the vector search, other one is the RAG pattern. We will first talk about the vector search, then we will talk about the RAG pattern, then we will see how we can build the generative applications. I will also demo you some real world applications. With that, I will start my presentation. The topic is going to be today RAG patterns and vector search in generative AI. This about me, and I'm Udaiappa Ramachandran. You can shortly call me Uday. I work for a company called Akimina as a CTO, CSO. I'm also in Microsoft Azure MVP. I've been in this space more than 12 years. I started with Microsoft Azure, then built a SaaS platform in Amazon services. Worked a little bit with the Google, but not really employment. I run this user group along with Dan. Dan and I myself run this user group. So that's where you are here today. This is my personal community profile. If you want to see what I'm speaking, then I leave it over there, recordings, links, and so on. Today's agenda is going to be keyword search. We set a vector search, right? Before we dive into vector search, we want to see what is keyword search, then we will see the vector search. Then we will see the hybrid, best part of both worlds, right? And then vector embedding. You need a vector embedding in order to do a vector search. Vector embedding is also called a semantic. And then cognitive search. Then we will talk about the RAG patterns and so on. So keyword search, you all know that, right? It's a very popular. You take any system, you have some sort of keyword search. You go to, if you build any application in your own application, most likely you use the keyword search. The database, you send a search query to the database, they are keyword search, right? You're sending something, you're looking for something. It could be a full text or simple, but you send some string and you're looking for that, right? So it's a simple and easy to use. We use it any database application. In some of the search engines, the old days, use the keyword search. It's a fast and efficient, scalable to a very large data set. There is no problem because it uses the full text index and brings everything to memory. So you are able to query that. Well supported, right? So that's the era we've been, right? So keyword search. Cost-effective, easy to implement. You can pick any technology, starting from the SQL to Azure Search to any search engine you take, you can perform the keyword search. But the problem is it's inaccurate. For example, for the complex queries, it may have a different result than the one that you expected. It's very sensitive to typo, right? You miss a one character, it's not going to find, because the way that keyword search works, it takes your keyword and looking in the keyword dictionary, it presented exactly, right? So you're looking for something like apple, so you're going to miss one letter L, then it's not going to find out. But the semantic is a different way, right? So it is very sensitive to misspelling. Does not understand the semantic relationship, right? So where exactly tag and cat, right? So how the semantically they're represented, how they're related, right? So those things are tag and bus, right? How they're related, they are completely two opposite things. So keyword search cannot understand that. That's why the vector search come into a picture. Language barrier, so it can't understand the multi-link word. So you just implement for one language. If you need another language and you need to implement that. So again, this is not new. This is what we've been using it. So if you look at how the pipeline works, you send to something, and then query parser, either takes a simple or full text, and then it analyzes the token, and you send this to a search token, and you ask, it returns a result, top 5, 10, 20, whatever you ask, it returns it. But again, it's going through the keyword library, right? So you have a document apple and banana, you have a document orange and pears. You have another document, Apple. It's kind of the document A, Apple, how many times appeared, and all those things, links mapped, and then you look for the exact word and returning you the document links. So vector search, right? Vector embed search. Vector embed search is nothing but, it uses the vector embedding, which is the array of floating numbers, right? So we'll deep dive into it. The advantage of it is a better understanding the semantics of a language because it's now similarities, how your word is similarity arranged three-dimensionally, right? So it represented in the form of numbers. There is algorithm, there is a model, then it gives you if you send apple, it sends you a dimension of that word apple in a multiple dimension, right? The model provider, for example, OpenAI or Hugging Face or Google or Amazon, whatever the model you pick, they define the dimension how you want to do it, right? So if you use an open API, it always 1,536 vectors it will give you. Even you send a one word apple, it's going to give you 1,536 vector because they can't dynamically change the vector size. Apple is a one word, they can give you a one vector. Or you send an entire document that takes 2 meg, you're still going to get a 1,536 vector. They arrange it such a way the words are how it's related in your document. That's how they're going to find when you type something. That's why when you make a mistype, they know from the floating number and the relations how they can retrieve the document correctly. Okay. And with these techniques, it can just complex and ambiguous queries, more robust. You don't have to worry about typo spelling because it does the similarity search, so that problem is gone. Cross-lingual search, so you can now bring it in a multilingual across the languages because it uses the similarities, right? The disadvantage are, the cons is computationally expensive in the past, but not anymore though. Now you can do it. There is a lot of engines in the market. We will see some of the top engines. You can do it, but 2 years ago, it was, nobody thought about it, right? Even if somebody in your job, they ask you to do a search engine, you most likely be all going to build the keyword-based search. But if the employer asks now, or anyone asks us now, we most likely going to recommend vector search. The keyword search almost dead. I mean, it's still there for a simple use case scenario, but if you want to take advantage of the AI, the natural language, you obviously have to use the vector search. You will see why. It's more difficult to implement and maintain, requires large data set of pre-trained embeddings. We are not doing it, but the model provider will perform all those things. But we obviously have to pay them based on number of tokens that we're going to generate the embeddings. Not as well supported by existing search engines, but the current search engines, Google, Bing, they all use the vector embeddings. So how it works in the pipeline, right? So you have a data source. I'm feeding here some sample data source. It could be anything, images, right? Images of type PNG, JPEG, and you name it, right? And then audio, MP3, MP4, or any format you want it. And then video, right? Same thing, MP4, whatever, video format, and then the text. The way it works, you take that and you send it to an embedding model, right? The embedding model is going to send to you a vector representation. So this varies how many vector is going to get, right? The text for a text embedding, OpenAI returns the 1,536 vectors. For image embedding, OpenAI is not publicly available, but there may be some preview. But Microsoft Vision API returns the, I believe, 1,024 vectors, right? So that's how it is. So you're going to get the vector, and then if you want to store the vector in a database, you can store it. So in some reason you want to regenerate, re-index the content, you can index it, or directly put them in the Azure Cognitive Search. Today, in Microsoft Azure Cognitive Search, this is now called Azure AI Search, right? Can store the vectors, can query the vectors. Right? You take the document of any type, you transform to the embedding provider, and then you store them in a cognitive search. That's a left to right flow. Now the right to left flow is your end user comes in and he is looking for something. Hey, can you give me, he can ask natural language now on the vector database, but not on the keyword based search. The vector database, he can say, can you find some apple, right? But it's going to take the intent is apple and it's going to transform the apple, and then apple is transformed into a vector, and then vector is sent back to the Azure Cognitive Search. Cognitive Search now takes the vector of apple, search against the vectors stored in the Cognitive Search, and it's going to find the result and return back to the user or the app, right? That's how it works. So left to right is the backend design. You generate the vector, you put on the index. Right to left is the app. It asks something, in an AI world is called a prompt. Is ask something, then if you want to use AI, you use AI to get the intent. What is the intent of the user is asking, and then you get a vector embedding of the intent, and then you send that vectors to the Azure Cognitive Search, and it's going to return you a result. There are other engines we will see, but in this particular demo today, we're going to talk about our AI search or Azure Cognitive Search. Now, the keyword search, the vector search. So what is hybrid search? It's hybrid of both worlds, right? So you can do some filter using the keyword search, the other filter using the vector search. So how that works? You have a field called, for example, first name, last name, and then your complete work experience. Okay, so assuming that your work experience is vectors, right? Now you can filter. I only want to know department is the best example, right? So first name, last name, department, work experience. So the department is not vectorized, but the work experience is vectorized because that's going to have a blob of text, right? So you want to know all the similarities, right? Who knows the technology, years, and expertise, and so on. So now you can do a filter. Okay, department equal to so and so. That's a filter. But first it runs the filter, then you can do vector search, right? Which is semantic search on top of the filter result. Okay, that's the power. That's a hybrid. So best of both sides. Now you have the keyword search that returns your filter, and then the filtered result you go into the hybrid semantic search by using the vectors, right? So you're looking for something. Show me a person who is being expertise in this technology, did so many things, right? That's a prompt, and you're going to generate the intent of the prompt vectors, and then you send back to the vector search of the department that you filtered or using the keyword search. Okay, so that's how the hybrid search works. And as you obviously know, the benefit is improved accuracy because you already know what you're going to filter. You're going to filter only for the department, so that itself gives you accuracy instead of you putting everything into a vectorization and then trying to look that may not give you the accurate value. Increased relevance is wider range of queries you can apply to. So here are some real world applications, so for example, product recommendation, right? So if you take Amazon, you buy one thing, they recommend other thing. Okay, on any website, any e-commerce website, you buy one thing, they recommend other thing. How they know that they can recommend this to you? Because of the vector, because the people who bought before, they bought the other things, right? I bought X, I also bought Y. Now you bought X. Well, most likely you may buy Y because that's the similarities, right? So that that's a true data. Even with the true data, we can figure out, in this group, everyone buys X, and I bought a Y, someone else bought a Z, someone else bought a Y. Then there is a possibilities, rest of us can buy X or Y, right? That's the similarities. Those things, is a product recommendation. You bought this, you can buy this. Those are come from the vector search. They take your user-generated content, they vectorize it, and then they ask you what you will buy, what you can recommend, and then tells you, based on the similarities analyzed in the system, this is what recommended. Anomaly detection, document search is the great thing, right? So you look for something within the document repository. If you do a keyword search, it may not yield you accuracy result, but semantic search will give you accurate results. Vector indexes search is nothing but semantic search. Google search engine uses the vector search for a long time. Facebook recommendation, Netflix recommendation. If you go to any recommendation engines, they all use the vector search. It is impossible to do a keyword-based recommendation. So how the vectors are generated? Vector itself is generated, right? The vector itself is generated by taking the, they call it as the cosine similarity, but a little bit mathematics involved, and we don't have to go deep dive into it. Just for understanding, let's have a very glimpse of what it is. Cosine similarity of x and y is there is a formula, dot x and y, and mod x to mod y, right? X and y are two vectors. And then dot xy is the product of the two vectors, and x is the magnitude of the vectors. So x, you take a 3, 2, y 1, 4, and then they apply to the formula. It's going to come 0.745. This is how they find the match, right? That's a vector match coming in. So now these just a 2 point. Now assuming there are 1,536 vector points, now you have to put it in the dot 1,536 divided by mod of 1,005. So that number is going to grow bigger. So that's how the vectors are calculated. But just to understand, so cosine similarity is the takeaway. We don't need to deep dive into the formula unless we are the one going to build the model. Now the vector databases, right? We've seen how the power of the vector embeddings and vector search. So what are the other databases available in the market? Pinecone is the number one. They have managed the service, high performance and hybrid storage. I believe Azure Search will support Azure storage, hybrid storage, or Cosmos DB will support it. But hybrid storage is, is a hybrid of both worlds, in memory as well as the disk, right, for the fast retrieval. Qdrant, open source, highly scalable, and it gives a filtering options. That's what I was telling you, right? You filter it and then apply the semantic on top of it. That's the power, right? So you know that you're looking for a particular department or a particular product, then you look for similarities, right? That's always going to give you a more accurate than looking everything in a semantic way. VV8 open source that supports semantic search, modular design. What does modular design mean here? It let you pick the best machine learning model that you want to use in your search. Milvus open source, cloud native, trillion scale search, large data sets. FIES is a library, not a database by Facebook. It brings the advanced algorithm integration, then integrate with the traditional database to look for some information for a semantic way, right? So now, here I never listed the Azure search or AI search. Cognitive search is now called AI search. I forgot to change all those things. It's, why AI search? It gives a keyword search, vector search, hybrid search, very advanced filtering, semantic re-ranking. You can re-rank after semantic re-ranking supported. Built-in chunking. If you have a large document, it automatically chunks it. Okay, and then store it. When you look at it, it will give you which chunk part, which page number. Chunking is nothing but a page number. Okay, you have the data and so on, and then bring your own vector. So you can generate a vectors and you can store it there. So and then you can query. But the key takeaway here is if you generate a vector from one model and you have to query, so when you send the prompt, you have to query, you have to generate, say you have data that you generate using the OpenAI, right? Now you're looking for some information, say Apple. Now you have to convert Apple into embedding vector, right? You have to use the same OpenAI model. You cannot use another model to generate the embedding, and then you send it to OpenAI. It's not going to produce the same result or accurate result. So wherever you generated the original vector is where you're going to look for the prompt or intent or whatever the user query is trying to do. Okay. With that, we'll explore a little bit on the vector search and then in the AI search world, and then we will get into the RAG pattern. Then we will see how to build the application. Any questions so far?
Do we need to know trigonometry for any of this?
Nah. It looks a lot of math, but now everybody, they simplified it. We don't need to know anything except writing few syntax corrected code. So I'm going to go over here. This is the system I'm in right now. Right. So first, what you need to do, you need to create AI search. Okay. So create AI search. And then you need to enable the semantic rank. Okay. If you're going to learn, you obviously can use the free, select the plan. I don't want my demo to fail, so I selected this plan. Okay. First 1,000 requests per month is free, and then $1 per every additional request. You must enable that. It gives you up to 3 vector index created. So when you create a vector index, you can go here and you can see how the vector index are created. As you can see, I have one vector index. Whenever you see the vector index size is more than 0, that's the vector index created deal. So I have some users I populated, 44 users, and that vector size is this much. Then I have some text-based document, 108, and then I have that vectors. Okay. So those are the 2 things. But this you either you can hand create or you can configure programmatically from the, you have set of files somewhere in the blob storage, and then you can configure it. So when it synchronizes, it converts them into vectors and writes over here. But when you hand create, you have more control. You can now create indexing of more field, right? For example, if I look at it, this index over here, right? So if I look at the field, I have a lot more field, right? Along with some of the vector field. So this people vector is a vector field. It's a single collection. The length is going to be 1,536 vectors, right? But if you ask the, automatically do it, you don't have that flexibility to inject your own field, right? Now I'm bringing it, so I can bring it any number of field, and I can generate a vector for this particular column, and then put them in a, the way that this vector is generated, we create all the data, we put them in a Cosmos DB, and then we link the Cosmos DB as a data source to the search index, okay? And then we create this column as the single collection column with size 4:1536. If you have a image that you're going to store it on the same index, then you probably have to create an image vector, and that size is based on whatever the model you're going to use. Today, you're most likely to use the Microsoft Vision APIs. If you use that model is, I believe, 1024, so you can use that one. Okay, so that's how you start vector search. But now let's go look at some of the coding, how you can run it. This is already available in one of my Git URL, and I can show you the end of this topic. If you look at it, it's a very simple code. Okay, so we have the controller. The controller has 3 functionality. Okay, so the constructor takes, you want to do a text search, you want to do a blob search, right? Blob is nothing but you create an index by storing files into some of the blob storage. Again, these are only text. If you have a document that contains the images, it's not going to do anything to do that. It's only a text. It takes a text of the document and sending it back, sending it to embedding, and then takes the text embedding. That's why the model called text ADA embedding, not the image embedding. You have to do it in a different way, right? In the future releases, they may support, how to generate embedding the document that contains image and so on. But right now, even your document is going to have an image, it's not going to worry about it. It only takes the text of the document and then embedding it. Okay. If you do it manually, I will show you how you can do it manually. Then you have to use some third-party libraries to extract the data. So for example, talk to text, right? So if it is a type TalkX, I use this TalkX library and then extract the title and content. And if it is a PDF, I use this PDF reader from the agency, iTextSharp and then Excite. You can use any third-party library, right? So the advantage of you extracting this data, like you can inject more field now. Right? For example, you're building a multi-tenancy application, you want a tenant ID, you can inject it, or you want something, so you can inject it, date created, and so on. So you can inject multiple metadata to it. But if you have a system to do it, they're always going to go to predefined field. I will show you how the predefined field look like. So if you go back over here, this one is self-created, right? Created by the automated, right? If you look at it, only a predefined field. Category is manually added. Title, content. You can also inject there some field over there, but it's up to you. So you can generate a vector, or you can ask them to generate a vector. But if you need more field and dynamically, but it's a better way to create is you want that vector generation process instead of asking the system to link. Right. So let's go back to this code over here, right? Now we have the text search, and then so in the search method we have only 3: create index. That's how we're going to create an index. Convert to text, as I said, this is only when you want to hand create the vectors embedding by manually calling it, then you will use this method, like extracting the document to a text or PDF to a text, only that part. Otherwise, you're going to go search index. Okay. So I'm going to run this. Is the parameter set right now? Right now set to a text search. Okay. So I'm going to run this. So as I said, I can call create. So if I call create, I'm not going to create it, but I will walk you through the code. For example, for text, if I call it create, it's going to come in over here. I have a sample JSON, right? It's a text. I'm going to simulate some record set. So if you look at this data set here, it has some data, ID, title, content category, ID, title, content category, and so on, right? This has this. We have some sample data to generate. So it takes all the sample data. This sample is also available online. I will point to you everything online available. It reads it serialized to a dictionary of string, string, and then it creates some sample document. If you go back to the sample document over here, it just, title, and get the embedding of the title, get the embedding of the content. We're just manually creating this, okay? Embedding of the title, embedding of the document content, and then you set the title vector is equal to title embedding. We update it because if you look at this over here, we said we created it, but the other one is the document created. So if you look at the IDS document, that might have less field than what it contains. So, this contains a junk, title junk, and we manually injected category IDs. Okay, so let's go back. Then you put them in the document. So all we do is we take all the documents in the JSON, it's a record, right? Assume this is the record, 1, 2, and so on. And then we generate the embeddings. If you go back to the embedding method, it calls the OpenAI client to get the embedding and then passing that into a string over here. That's all we do. Okay. And then it returns the embedding of that one. That embedding is going to be 1536 float array. Then we call the index the document. So first we create the index, we load the document, and we create the embedding of the document. Then we add it to a index document. We upload all those things into an index document. That was indexed over one of these index over here. So if you go back, this index over here. Okay. All right. Now we need to query it, right? So if you go back to the system over here, now I want to query something, right? So I'm going to say, right, Azure, look for Azure, and I'm looking for, this is category equal to compute. This is both side world. Now we can do categories keyword filtering. Azure is the free text, and the search type. We have 4 different search types. We will look at it one at a time now. So if we execute it, set a breakpoint. I'll tell you why we need to do. You will understand the benefit of all those things. So if you set the breakpoint over here. Okay, so it's a simple vector. Okay, so if you go back to the simple vector, let's jump in over there. So it's going to come over here, right? The query is Azure, right? But what we're going to look for is like 1056 array. This is what we look. We are not looking for Azure. We're going to send this byte array, this float array, to search index, and search index is going to look at the vector column to look at the similarities and return your result. What you are looking for, Azure. What are you going to query? The size of 1536. Now think that you have 1 million records of just fruit name alone. Then every record is going to have this many size, and every float is a 4 bytes, right? Then obviously you're going to have a large number of database. That's why the size storage is the matter here. Okay, anyway, so here is the search options, and then you're passing it. How depth I want to go, right? So I want to go left to right. How many neighbors I want to look at it. The more you depth it, neighbors you go, the slower it gets in, right? The result may not be accurate. So you want to be as close as possible. And then you tell them where is the field is. The content vector contains the content vector field. So it takes this vector. It's going to, semantic search on this column. Okay. And then you move on, and then it's going to return the result. And if you set the breakpoint over here, you got some documents. Okay. Run it. And then we got some document as a sphere, and as you can see, the scores is over there. So when you look for Azure, these are all the score, and it found the top 3 highly rated data from the database. But again, this came from the Azure. This came from the vector search, not a keyword search, right? You're looking for Azure, it found something about that. Now, similarly, you can do two. If we go back to the code over there, I'm directly going to jump forward because we will be running out of time. Text search. Yeah, single vector search with the filter. You understand that. So if you go back to the filter, the first one we sent a filter, but it didn't apply it. But the second one, we put a value for the filter because it's a required part of the parameter, but we didn't use it. For the second one, we're going to use a filter. So that's where category equal to compute will be used. But in this first query, category is equal to compute is not used because we did not pass it in. But we have a parameter here. That's why we pass it in. The second one is going to use a filter. Third one is a simple hybrid, just looking at the vector alone. Fourth one is the semantic hybrid. You filter it, and also looking at the searching against the vector field. Okay, so now let's run this sample quickly. Execute. We got no result. I don't know why. Compute. Maybe it's looking for filter compute as a capital C. I don't know. Let's look at it. Okay, so that's casing issue. Now we discovered, right? Now we're going to look at the 3. Yeah, this got some ratings 0.3, 0.2 because it's a hybrid semantic search. But now we're going to, so this is the result of semantic search, right? This has something, but now we're going to do a hybrid semantic search. 4, you look at it, the result will be completely different. So it rescores it, okay? That was the original score, but because the re-ranked score is 2.9 and so on. So you will see the re-ranked score, and then it also tells you how to highlight and all those things. Why this is important? This is what we're going to use in a RAG pattern when you build a system. We'll see it in a second. Any questions so far? And similarly, you can you can search the document by changing the code to look for the documents. Again, this demo is only focusing on the text-based search, not the image is not there yet, or videos and so on. It's not there yet. The OpenAI right now full support is the text-based search. Okay, so you can get a text embedding, store it, search it. And Azure AI can do anything, but OpenAI cannot do image vectors right now. But if you need an image, you want an image search like a face search, right? You go to the Google Photos, it tells you, oh, this person is this name. How it knows? It takes the face and then it vectorizes it, and then it checks against the vector and tells you the similarities. Okay, this person is this, right? So if you want to do image search, you need to generate a vector using the Vision API, store it, and then you upload a fragment of image, and you get a vector of that image and check against how many documents, the images that matches that the image you sent it. That's how you can build one. I'm still working on that, but this demo is working, but not accurate image search, but you can play in the online. If you download it, this I completed. So you can download it, uses the search API, Vision API. You can look at it, how it's working, searching the images. Okay. All right. Similarly, the blog. Let's move on. Any questions so far?
Would you be, do you see any scenarios where you might use a combination of different searches, or maybe like first you show them one type of search and if they hit more, you do a different type, or just sort of thinking of the use case?
Yeah, I think this is what I'm saying is the part of this talk is to learn RAG, right? Retrieval augment generation. Hold the thought process for a second. I'll come back to that. So let's dive into this retrieval augmentation, right? So this is some of the term that every AI developers or company is talking about, RAG. So what is retrieval augmentation, right? When you talk GPT, which is either OpenAI or Google or any GPT that gives you generated contents, right? You are talking to their model. You're sending some query to their model. You open a chat.openai.com. You're asking create a content, right? So and so. It generates you. What happened? It takes your prompt, sending it to the model vendor API. and then it look at their system, how their similarities learned, trained the model, and then it retrieves the content and give it back. That's how it works, right? But now, what if you're looking for the information that is not publicly available? That information is available, you working on a project, that information available with your company, or that information available with your, you working on a personal project, that information available within you, in your system, or in your personally owned account or personally owned storage. But now you want a generative AI to generate a content or provide the information that you own, not from the model, right? So there's two things you can do. If you want to spend a lot of money, you can build a new model and you can store the content, but that's a lengthy path, right? You want to look at the sort of things. You have like hundreds and thousands of documents. You want to look at few things over there, but you don't have to build that model. That's building a model or tuning the model is always an expensive path. That's one way of doing it. The other way of doing it is you retrieve what you need that personally owned or which is not available on the public model, right? You retrieve it using these search techniques or semantic search techniques, precisely say, and you pass this part of the prompt to OpenAI models or any model that, GPT models, right? And they're going to use your prompt and use your content, and they now give you back the response. You will see it in the demo, but that's how the retrieval augment generation comes in. But I want to highlight one thing. I know people talk about the RAG and they talk about this vector database. RAG is not necessary to have a vector database. You can write a simple datetime without, you can still call it as a RAG. Things that cannot be done by default model, if you do it by injecting your own data, then you obviously using the RAG pattern. You clear? That's the takeaway. The RAG does not need vector search or vector database all the time. You asking for something your model cannot give you, but you can inject and you can return the data, then you are obviously using a RAG. For example, daytime. You go to the model, you ask what time it is now. It cannot give you. It's going to say, I'm an AI model trained and cutoff date, so and so date. But it can't tell you the daytime. But you insert the pipeline. When somebody asks the prompt daytime, and here is the pipeline, right? Here is the plugin. Then it's going to return you from your plugin. Then you are obviously using the RAG. Okay, so the key takeaway is RAG has nothing to do with the vector database. RAG has how you use the system. That's it. So here is the flow. User asks a question, what time it is, right? What is my, very often if you read the internet, you will see an example, what is my health policy or company policy, or what is my vacation plan, or what is my employee handbook suggest, right? Or something like that. That's the private data. If you go to the ChatGPT or Gemini.google.com, you ask, hey, what is my company policy for vacation, right? It can tell you. It's going to say, no, I don't have access to your company data. So how you can do that? That's your question. Your user question is, hey, what is my vacation policy? Let's query my data, right? How you query the data? Because obviously, your vacation policy is not in the GPT, publicly trained GPT model. So you're going to go back to your database. You can use a keyword search, or you can return some hard code value, or you vectorize all your document and you look for it, and then you return the value. So it's going to look for what is my vacation policy. The intent is vacation policy. It's sending back to the semantic search. The way you're searching semantically is going to be more accurate. And then it's going to return some result, and you embed that. Add that result to a prompt. So your original prompt is, what is my vacation policy? But now that is stored in your database. You can take the data and you can append it, right? You are not going to append it. If it's a semantic kernel, it does all the thing for you. Prompt it. Then you're going to send that to the model. Now you're still sending that to a model that's publicly sitting in the internet. But whether they're going to use your data to train the model or not, you have to refer the vendor's policy. Okay. But if you use Azure OpenAI, or Azure OpenAI safety says, they will never use your data to train the model. But you may ask a question, will they see the model? Of course, you are the pipeline. You're going through over the internet. Yeah, your data is going through internet to their engine, but they are not going to store your prompt. They are not going to use what you queried to train their models. It just you request and response. That's it. It's done. After that, it's done. And then it's going to use the language model, sending it, and you ask what is the benefit, and you also find the benefit from the search result, right? Now your company, you look through your company documents and you found a blob of text, you're passing it part of it. It's going to use that blob of text to return your result. That's it. That's a RAG. Again, RAG is not always a required vector database. It can be a simple data or you can return a simple text. Right? Vector database is more, makes sense or more powerful when you have lots of documents that you want to semantically search. All right. So here is some simple architecture, right? So you have app UX, app server orchestration. You query something on the search, then you pass it part of the prompt knowledge, and then it returns it. That's what we see it over here as a flow, right? But here we don't have any vectors. You can do a simple search, right? You can look at your database, return the data. You're asking for find the people who joined after so and so date. Okay, so you have to have your own plugin. It will execute, and you go to the database, and then you look for some data, and then return the result, and then they're going to send that result, and then Azure OpenAI now creates a new response using the data you provided. Okay. So memorize this picture. Now watch this. The only difference is transform into empathy. Okay. Now you can semantically query the data. Okay. App server query. Now, this all stored in a vector index as an embedding now. But again, now you're running the semantic query, not the ordinary query. And then you send back to the result is going to come in, and you send back to the AI model, and it's going to send you a response. Okay. It's very clear, right? Very simple, right? That's how everybody building the application. So if you want to build an AI application, RAG is the easiest way to getting started. But after that, based on how your requirement change, you can take a different path. But within the RAG, there is I found that the multiple way you can build application today. The one is Azure AI Studio with the prompt flow. If you want to explore how this prompt works, how they do a system prompt, meta, also known as meta prompt and user prompt, and one-shot, two-shot example, and all those things, the very best way to learn is go to Azure AI Studio, and then you explore it. It's a playground. Okay, you explore it. The second thing is, you want a website, you want to create a Q&A kind of things, right? So you have a website and a support website. You want to create a bot, and you can go to the Copilot Studio and then just 3 clicks, you have your site has become a bot enabled thing, and then you can add on more documents as a RAG, right? Retrieval augmentation. You can add some documents, you can set some filters, you can put the emotions, sentiments, and so on. All the range of filtering effect you can set there. Third one is, that's what we're going to see today, semantic kernel, application development, right? So you want to build application, how you can do it. Semantic kernel is one way. Semantic kernel is there in the market for almost 6 months now. If you look at 6 months ago, it was very early. The last December it was RC1. Now it's a 1.6.1 release. And then it's .NET is the number one. If you look at AI, most people will talk about the Python and so on, but the semantic kernel talks about the C# as a first class block builder, which is a good thing. Like if you are a C# developer, I'm a C# developer, it makes you feel good, and you can build the application now. That's the application we're going to see. Okay, so let's look at some maps over here. All right. So what we're going to do, as I said before, I'm going to stop this demo. We've done this. I'm going to run a very simple demo. As I said, the RAG pattern, right? So let's do this. Let's run this one. So this, again, these samples you can download, but this is we download and then we're building a product. But you guys can do the same thing. I will point to you where you can download the similar code on the internet from Microsoft. So if you go to github.com/Microsoft/chat Copilot, you will get these projects. And then you will also get this web project, which we are not using it. We use our own interface. But for demo reason, I will use this project. So here is the project is running. Okay. And my web is web are running here. Yeah, it's loaded. All right, now let's go back here and then reload it. I'll run 2 samples one at a time, and then I'm going to run a bunch of samples. Occasionally, it will get this runtime error. Don't worry, just run it. If you get that error when you run your samples, you have to do this a couple of times. All right, I'm going to ask, so this sample, if you download, write about Redis cache, right? It's going to definitely write. Okay, so now it opens the chat model. Behind the scene, I configured the OpenAI, Azure OpenAI. It's going to use the Azure OpenAI, and then it writes me. Right? It knows what is Redis, and it's writing it. And I can contribute. That's a user prompt. My user prompt is write about Redis cache. Now I'm saying what time it is now. What time here now, right? What time here now? Okay. Still, the current time is 8:53. It's still returns. Did I comment it or no? Check, yeah. Oh, somehow it knows from this prompt, so it's returning it. Sometimes 6, yeah, this is accurate. It returns from this persona, I guess. So it not return. Are you sure? Okay. So it returns it. I'm not sure how it returns it. I believe based on some data somewhere it return it. But if you go to the Chat GPT, OpenAI might not tell you what time it is. It may not tell you, or what time zone I am in, or it may not tell you. So the way that you intercept that call, you add a very simple plugin, right? So I'm going to uncomment this. Well, you're going to uncomment it and then say, it is now and then R, right? So I can return anything I want. It's just a string, right? So I can say, I'm just going to say ABC : datetime.now, and I stop it, I run it, and it should use my date time helper, right? Debug. So let's do multiple things instead of doing it, right? So now since we're building it, we want to build a target. So if you can go to the ChatGPT, you ask to generate an image, right? You say like create an image, it will create it. So how it create it? Because it will translate, create image into it's a intent, and then it will call the Tali plugin. So that's what we do here. So we have the plugin called Tali plugin, and then we name it as a create plugin. So anytime we ask create an image, and it knows smartly how to invoke this plugin. So plugin is the way that you extend your system. It's also called function calling. Anytime that you can do few things and you're going to do a function calling, that's how it call into your function. Your function can be a native that runs part of the application, or it can be a remote. Your function call or plugin can be some sort of REST API, right? And then here is another example. So what we do here, we call it as the people finder, right? So I want to find my name, Udai. And obviously it can find Udai is a very generic name. It's not going to find it. Okay, so what we can do when someone looking for Udai, and it obviously find it out which is the right plugin, it's going to load this plugin, People Finder plugin. People Finder plugin is going to look up the database behind it, and it's going to return it. Or whatever the implementation, it's going to return the data. Then it will tell you who Udai is. But if you go to the chat.openai.com, type find Udai, now definitely not going to find Udai because it's the most generic name, and I'm not celebrity either. Okay. And this is some way of custom plugin. If you don't have native plugins, you want to extend it load dynamically. You want to, you want to expose that functionality to your customers to write their own, bring their own plugins, and the custom plugin come into the picture. All it takes is the REST endpoint. The REST endpoint should have the function declaration called kernel function. Well, now we talk about the plugin, right? How this plugin itself is developed, right? So if you go back to the plugin over here, this chat is a native. And then, for example, I have Bing search, right? If you do a Bing search, right, all you need to have kernel function. That's the only attribute you have to set. Once you set the kernel function, and then you have to set the name. Once you set the name, then you set some sort of meta prompt, like search Bing for specific query and returns the result. Okay. Then it's going, anytime you ask something, do a Bing search, it will invoke this function and then get the result and reply to you. Similarly, DALL-E function, it uses the DALL-E and say, this is the function generate images from the description of the image to be generated, the number of image to be generated, and then it calls the implementation behind the scene. The email, similarly, you look at it, you email it. So you find a person data, right? This is another plugin. So you want to look at some people, it's going to send what is the user intent, the query to be used from the people, and you go back over there, and then this is going to use the semantic search, and then find this is a filter to filter the particular tenant, and then use the semantic search to find the data. Then you return the data, then the OpenAI will summarize my result and return back to me. All right, so let's go run this one. So before I run this demo, I also wanted to show you one more thing, how you can do, I'll come back to it. All right, let's run this one. Debug. Start new instance. It's loading. 3 seconds. Any question while you're waiting for?
So I think this looks really cool. So for instance, with what you just shown us, we can literally say, hey, Jen, please send the end of year report on the XYZ widgets or something like that.
Yes.
Versus a question, but a request. Wow, that's really cool.
Yeah. Yes, exactly. This is very cool. I mean, the building it used to be very hard, right? Nobody thought about AI, but now it's much easier to do anything AI. You would be AI developer after this meeting. I'm sure you all will be AI developer after this meeting, if you haven't done that before. Okay, so now this function is loaded. We're going to go back and open the chat interface. Refresh this. I use the Microsoft chat interface sample, so refresh this. I got it. So I'm going to talk about, who is Udai, right? I don't have to put a question mark. I can have broken English, whatever I want, but it will semantically correct it. So it's going to say, I'm sorry, right? It does not know who Udai is. What I'm going to do, I'm going to force this to use my plugin. Okay, I have something like a people finder. So I'm going to say, enable that plugin. If you, this is the UI to load it, you can programmatically call that one. If you do, for demo reason, I use this UI, but some places I use it programmatically. I enabled it now, right? So it says, I'm sorry, but now I'm going to ask, who is Udai? Right? Now it knows that I have some plugin turned on. It's going to query our plugin data based on the information I found, the individual name Udai. Now it knows who I am. How it knows who I am? It now piped back to my backend system and take the data, send back to the OpenAI and finding it. Okay, list all the people who is reporting to him in a table with first name, last name, and email. Okay. This is not a real data, so I can show you the real data. This is some test data. I think we just list all the people who is reporting to him, and it's going to find me first name, last name, email. It found some data. It's returning to me. Isn't it cool? Now I got it right. Now I'm going to say send an email to Madison with a subject meet now and body as at the Gordon conference. Okay. I did not set a breakpoint, but I will set a breakpoint. I forgot to set a breakpoint before. But if I asked, when I asked every time I search, it will come in. But now I say send email. I put too many parameters. We never hard code anything. If you set a breakpoint over here, right? And then I do a send. I didn't give any email or anything, but it knows how to send to him an email. It should hit the parameter. If you look at it, it has that to address, Madison. We didn't give the email address, but we set a subject, meet now. It even corrected the cases, right? And then body at Gordon conference, and it corrected it, and then screen calls, and now our code will send an email address. Enter it. Okay. All right. So you got it. So that's how it works. Okay. I successfully sent an email address. Now, one last plugin that I want to demo you. So this is how you call all these things, right? But the one way that you can load the plugin, if you want to bring your own plugin, you can say the REST endpoint over here. It downloads that metadata a.plugin. But instead of downloading that metadata, I already pre-configured over here. I'm going to start that service. What that service does is, this all it does. This is the Hue Light plugin. So, right, I have some plugins, a fun plugin, right? There's nothing new here. We have a three methods. So if you want to call REST over REST, you have to decorate with these three parameters. OpenAI operation, you need to give operation ID, and then the function, of course, is the HTTP endpoint. That's, and then if you need a security, you can add OpenAI security. You want to call anonymous or function key. For this demo, is anonymous, but I'm not going to run it all the time. It's not even going to run in a public endpoint. So it doesn't matter. So it goes the Hue client and then look at the get lights, all the lights. And the another method is the get state. And, if you give the light ID, you'll get the state of the light ID. Okay. The third method is the change state function. This is what we have it. But as soon as we give the metadata, it will communicate and download the metadata, generate the code on the fly. And now you can communicate to it. So I'm going to run this function over here. Debug, start new instance. Yeah. So it's running over there. Now what you're going to do, we just need to reload this one over here. 1 second. See, the plugin appeared. No, but I can add it. Let me stop and run it again. Let me stop it again. Let's stop it. It's going to stop it. Stop it. And run it again. So this we have this demo. It's going to be open source for customer to understand how they can build their own plugins and bring it to us as a fun demo part. We will have another sample how they can query their own database and so on. Now once that started, I'm going to start this project. Okay, so this project is started. Now let's go and reload this page. Hi. So now, back to state, but now it appears the hue light, right? So as a plugin. So I'm going to enable that. Enable it. Now I enable that plugin. Find my lights, right? Find my lights. So you are not going to see my lights. So I'm going to turn on the camera for a second. So if you look at my screen, there is a light over there in the corner, okay?
Yeah, we see your
light over there. Yeah. Find my lights. It's going to find my lights. I found all lights, right? So I'm going to say turn on, okay? Yeah, so you see it turn on, right? It's so bright. So now I'm going to ask change the color, right? Change the color to Microsoft Card 3 Polo. Sure, he always uses the red color shirt, right? So let's see how that's going to change it. So how it knows how to change it, we have the Bing plugin, right? It's going to use the Bing plugin to find what his shirt is, and then take the color, and then it's coming back and changing to the red. You're probably seeing it, right? So that's good.
Wow, that's awesome.
Change to a dark green. All right, it did that. So all right, turn off now. So you can, that intent not only the off, it can be shut down, or it can be kill my lights, anything you do that, similarity, right? Then it'll go on to turn off the lights. So that's how it works. So it takes it and find out the similarities and then pipe to the commands and what it wants. Okay. So how all these things are running together? So if you look at the code here, in the chat controller, right? So that's the external custom plugin. We load it. It'll go and load the plugins and then call back and all those things. Once the plugin comes in, if you were to set a breakpoint, it'll come here and then turn on and off the lights and so on. All you have to do, you have to put the parameter, how many parameters you want. When you import the plugin, right, it will extract how many parameters you have and then the parameter types. Then as you send to the user prompt, from the user prompt, it extract all the values and substitute for the parameter. We never said ID is 1, but it knows you're talking about ID is equal to 1. If you have multiple IDs, it will ask you which light you want to turn it on, all or one, or something like that, right? So, we never said color state is equal to something. We said change the color, right? We never said the hex code. It will automatically send the color is equal to red. It automatically creates hex of that color, and then the brightness is similarly. You can set the brightness too. So these all AI will do all the work, and then the plugins will patch. After resolving all the intent, it will call the functions with the decorated parameter. So when you import this plugin, it downloads the manifest. The manifest is going to look like this, right? Not here. Manifest. The manifest is going to look like this, and it imports all the manifest from the URL, and then it generates the code on the fly, and then as you communicate, it opens that endpoint in the target. Again, this runs in a different endpoint over here. Okay, this web project runs on a different endpoint. And then we running in the chat in a different endpoint. So this chat running in a localhost 3000 calls the endpoint main endpoint that hosts all these servers. You can find it in online, this sample code. And then as you type a command, this chat client, chat.chat ID, opens the correct plugin based on the information. So I said we have a Bing, right? So I'm going to say, find the next Microsoft build conference date using Bing search. Okay. But now it will find it out. But if you ask you open a chat.openai.com, you ask to find the next Microsoft Build conference, it's not going to find it. It's going to tell you my cutoff date is 2023 or 22 January or 22 January, and I'm not going to find it. But now it will find it. Why? We loaded the plugin, Bing plugin, part of this plugin architecture, right? So if we go back over here, we have somewhere we loaded the a Bing plugin, right? So because of that, it calls this plugin. So if you want me to set a breakpoint here, just never set a breakpoint. Let's do one breakpoint here. And then I go and ask. Again, right? It's there. Okay, so it's only the user query is what? What is the user query? Next Microsoft Build conference date. That's a user query. That's a semantic we are looking for. It's going to take that, vectorization and look against the data and bring everything back and so on. So just from it, we don't have to go through the implementation. So, and then it's going to give you the response out of that system. Okay. All right. Got it. All right. Next. So here is some links that you can go through. The two links that I forgot to update this slide, which I will update it later today, is the which was part of the last month topic, https://github.com semantic kernel. That's where you see all the semantic kernel release, latest updates, and so on. Okay. That's a project we are using for this, and Microsoft is working on Python and Java. As you can see, it's a very rapid release. Every week they update something. You can see that there's something updated yesterday. And then the chat that you see in the chat interface is Microsoft Chat Copilot. So you can download this samples. That's the exact sample I'm running it over here. Okay, so you can download it here. And this also gets updated more frequently. 2 weeks ago, you can look at it. So, and I will update that link and put it over here. The search sample that I was running you here, vector search API. Again, it's there in the tag, but now I will update the tag and available part of the meeting comment. Okay, so you can look at it. I slightly add one method today, but I will update this one. So this is again a very old one. I've been using it for a long time. Any question?
I have a question. Should I raise a hand or I can just?
No, you can talk. It's like I can hear you.
Okay. Yeah. So my question is that I saw that you have several ways to implement the RAG method. Which one is the best if we want to start with the implementation?
It depends what you're trying to do, right? So I showed you a lot of different examples here. One is calling the REST endpoint to do action of turn on and off, right? It could be you are sending email or approval or some sort of process that you want to trigger in. That's one type of requirement. Second type of requirement is you want to find some information which is available in your system or in your company. Then you're going to do some sort of vector search and bring the data back. Those are the two common. Third thing is the search internet, right? So you can search internet using the Bing or Google, and combine that information. Some of the feature information is not available on the cutoff date on the model you're going to connect. Then you use the Bing or Google search implementation. You enable that plugin part of your pipeline, and then you use it. Those are three common use cases. One is the actionable. You use that. Second one is the retrieval for the data. You have the data. It's a private data. You don't want to send it to public. You're still going to send it part of your prompt though, but Microsoft is not going to store that. Or they are not going to use the data, but they will still see the data to give you the requested response.
Okay. No, I was more about the framework.
The framework. Oh, I see. Yeah. So I think if you are a simple application, I believe you can start with Azure AI Studio. Our Copilot Studio. But if you build a enterprise application that does a lot of different things, then I would definitely recommend semantic kernel if you are a Microsoft stack of developer. Otherwise, there is a similar framework like a long chain for Python, I guess. So you can use similar things. So these are the common pattern: Azure AI Studio, Copilot, or programming, right? Semantic kernel is one way of using the programming tool. You can write your own programming too, or you can use, based on your language, you can use other framework like a long chain. Long chain is there for a long time in the market. We can use it. But in our space, it makes sense because we are enterprise software company. So we build a software, we can go here. So not a lot of flexibility for us to customize it, right? Because it's a multi-tenancy software, we need to control a lot of things programmatically. Then we chose the semantic kernel as the way to go. Okay. So if you explore a little bit, click here and there, and you will figure it out which one makes sense. And for us, semantic kernel makes sense because we are C# developer in our lab.
Yeah. Okay. Yeah. Thank you.
Yeah.
So this all three services internally calling the OpenAI only, right? Azure AI Studio.
Yes, yeah. For Microsoft services, by default, calling the OpenAI. But the cool thing about a semantic kernel is you don't have to depend on one model, which is OpenAI, right? You can call any model you want. You can use the open source models, Hugging Face, or even open source free model that runs on your laptop, Llama 2. Or Gemini model, or Amazon sort of Bedrock model. You can any model you want. You just have to write a little bit of customization. But if you use a semantic kernel, by default they give you an option to switch between a native OpenAI model and Azure OpenAI model. Well, you can bring any model you want. That's the beauty of semantic kernel. You just switch it in one place by configuration, by writing the little the plugin. Not plugin, writing the core, writing the little core, how you connect to the credentials, end service. But if by default, they're going to use it, but they also provide the RAG, right? So RAG is nothing but some sort of external data, right? That's what you learned it so far, right? It's nothing but some sort of something is not there. You want to bring it your own thing, but they provide you. Way to bring external data, either by indexing, or by uploading the documents. You can upload a document, you can ask a query, or you can create a search index behind the scene when you type a questions, and it's going to look for the search index, search the data, and then give you the new response. In Copilot Studio, it works a similar way, but I don't know we have time to see it, but let's see Copilot Studio. AI Studio, just for you guys to understand. And this one. Sorry. Okay, it's still loading. It's kind of strange. All right, so you want to create a new one, right? Just
so the Copilot also, it is charging some money every month, kind of billing.
Yeah, of course they are licensed. Yeah, so I don't have a top of my head how much it costs. Yes, they are. Nothing is free here. So you create a simple Copilot, right? You say something like a Copilot demo. Okay, watch this Copilot demo using Udai.io, for example. So let's go https://udai.io, and then I say create. Now I'm just building my Copilot. Now I need to take a snippet and put them on the website, and that's Copilot running on the side. It just takes a little bit of time. What you'll be waiting for? Let's go look at the studio here. So you create an OpenAI service, and then you go back to the OpenAI studio. It's done by now. No, it's still working. Now it takes time to. Right. So I so what's this? What is the latest article? I'm Copilot demo using. You see that that's a it even knows that that's my latest article. If I click on it, it's going to go. Definitely that's not the latest, but the second latest, right? Is there any article related to semantic kernel? Okay, it tells me, right? Yeah. Yes, there is an article related to semantic kernel. I go here and it's going to take me over there. Isn't it cool? I just built my Copilot. Now I can take the snippet and pay the license fee and put them on the website. Now if I have lots of documents, then I just enabled Copilot for my site. It's that fast it is. But this topic is also a RAG, right? How you can bring a RAG here? That's where it comes into this site. So you can bring a plugins. If you go back to the generative features, you can bring some sort of add another website, or you can add a document. I want to provide some more information from the document, then I can upload it over here. But as you ask a question, it's going to use everything that you configure. That's a RAG. Okay. So if I upload a document, that's a RAG. It's going to bring the information from here, and then you want to execute some plugins, right? Goodbye, how you want to change it. Someone asks, how you want to say, hello, welcome, how can I help you? Or once they're done, how you want to say, and all those things. You can customize it here. This is no code plugins. Okay, you don't write any code, just do it and upload the document. This one, also no code. So if you go back to the studio here, explore as a studio,